Hello and welcome to the logic of it all. In this video, we will talk about finite state recognizers. Previously, we introduced three types of finite state machines, where the type that receives an input and generates an output, we call them finite state transducers, and in previous videos, we talked about these. Um, Then we have the type of finite state machine that receives inputs but does not generate any output, and we call them finite state recognizers or acceptors. And the focus of this video will be on this type of finite state machines. And finally, we have the type where they do not receive inputs but they generate outputs, and we call them finite state generators. So, as I said, in this video, we are going to talk about finite state recognizers or acceptors. And the idea is that they receive a stream of input symbols, and instead of generating any output, what they do is they either accept or reject the input stream. So basically, we have some type of a specification for the input streams that are acceptable, and the task of the machine is to recognize inputs that are in agreement with the specification. So a very simple example would be in any programming language, if you want to use a name for your variables or functions and so on, there are certain rules that you need to follow. You cannot choose any combination of ASCII symbols as a name for your variables. And it is possible to design a finite state recognizer that reads a potential name for a variable, and depending on the programming language and the rules that your programming language has, decides whether that string is an acceptable name or not. So it's all about accepting or rejecting, and that's the only outcome that finite state recognizers generate. Now, if you want to be more specific, finite state recognizer has inputs, so it reads a stream of input symbols, but as I said, they don't generate any output. Of course, when they read the input symbols one at a time, they need to transition from the initial state potentially to other states. So there will be a state transition table, but because they don't generate any outputs, we don't have an output table for these type of machines. Um, and besides, all the ordinary states, there should be either one or more special, let's say, states that we call them accepting states. And in the diagram, we usually denote them by concentric circles. And the idea is that if your acceptor, if your finite state recognizer, after reading the entire input stream, ends up in one of those accepting states, then it means that the machine accepts the input. And if it ends up in any other state, then it rejects the input stream. And if you want to define this mathematically, you can say that a finite state recognizer can be defined with 5 components as a 5 tuple. So we have our set of input symbols that we denote with I, but if you want to compare this with a finite state transducer, we don't have any output symbols. Then we have our set of states, a finite set of possible states that the machine can be in. We need to determine which one of the states is our initial state, from which state we start the computation. And also we need to say which state or states are the accepting states. So A is the set of all accepting states. It may contain only one or maybe more states as accepting. And next is a function that, depending on the input symbol that is read and the current state, determines which state the machine transitions to. So that's your transition table, if you wish. And again here, because we don't have any outputs, we don't have an output table or an output function. And the final thing is, and this is a bit of terminology here, if we have a finite state acceptor, then there are strings that will be accepted by this machine and strings that will be rejected. The set of all input streams that are accepted by the machine, we are going to call that set the language accepted by that machine. Now, this term language will be used later on in other topics related to finite state machines as well, topics like grammars and also regular expressions. Now, to wrap this video up and to give all these definitions a little bit more clear understanding, here's an example of a finite state recognizer. So as you can see here, we have three states, S0, S1, and S2. And S0 is obviously our initial state because of this arrow over here. So we should start the computation from S0, and then we have our transitions. As you can see on each edge, there is only one symbol. So basically what it means is if you are at S0 and you read the symbol 1, you transition to S2. Or if you are at S0 and the symbol that you read is 0, you transition to S1 and so on. And again, if you want to compare this with transducers, we don't have the output bit on each edge. So if you remember, for a transducer, we said if you are at S0 and you read a 1, you output something, maybe a 0, and then you transition to S2. But because here our machine doesn't generate any outputs, we don't have that piece in the diagram. And finally, the state that has two circles around it, in this case S2, is the accepting state. So after reading the entire input, if the final state that the machine is in is S2, it means that that input is accepted. If it ends up at any other state like S1 or S0, then that input is rejected. Okay, and here's our first example. So the question is, if the input stream is 0, 1, 0, 1, does the machine accept this input or reject it? And it's very simple. We just need to read the input symbols one at a time from left to right and do the transitions and see where we end up. So we start from S0. The first symbol that we read is a 0. And with a 0, we transition to S1. So now we are at S1. And the next symbol that we read is a 1. Now, if you are at S1 and you read a 1, this edge tells you that you stay at S1. Then we read the next symbol, which is a 0. We are at S1 and we read a 0. Following this edge, we go to S2. And finally, while we are at S2, we read the last input symbol, which is a 1. And this edge here tells us that we need to stay where we are at S2. So we finished reading the input stream entirely, and the state that we are in is S2, which is an accepting state, and as a result, the machine accepts this input. And with the same machine, this time, if our input is 0, 0, 0, 0, 1, we need to repeat the same process with this new input. So let me clear this up. Okay, so the first symbol that we read is a 0. While we are at S0, we read a 0, which means that we move to S1. Now we read the next input symbol, which is another 0. We move to S2. And then while at S2, we read the next symbol, which is a 0. And with a 0 following this edge, we go back to S0. And then we read another 0. We use this edge over here to go to S1. And then while we are at S1, we read the last symbol, which is a 1. And this edge tells us that we need to stay at S1. So we finished reading the entire input stream and we ended up at S1. And we know that S1 is not an accepting state, which means that the machine rejects the input 0, 0, 0, 0, 1.